Picture this. The universe in all its vastness might simply be a hologram. A concept so mind-boggling it seems to be torn straight from the pages of a science fiction novel. Yet, this is the hypothesis that some scientists are seriously considering. In the grand theater of the cosmos, what we perceive as a stage of 3 dimensions might just be information imprinted on a 2-dimensional surface. It's as if our entire reality is a projection from this cosmic screen. Imagine the universe as a giant hologram, with every particle, every force, every star, and every galaxy merely an intricately detailed image projected from a distant cosmic boundary. This is the essence of the holographic principle, a radical idea that's been sparking a multitude of theories and heated debates within the scientific community. It's a concept that challenges our most basic understanding of reality, proposing a universe where the laws of physics might be drastically different from what we've always assumed. While this may sound like a wild conjecture, it's a theory rooted in the world of quantum mechanics, where particles can be in 2 places at once, and reality exists in a state of superposition until observed. It's a realm where the conventional rules of space and time cease to apply, and the impossible becomes the norm. The holographic principle further intertwines with the enigmatic nature of black holes, providing potential solutions to some of the most perplexing paradoxes in modern physics. It offers a new perspective on gravity, suggesting that this fundamental force might just be an illusion, a holographic artifact of quantum interactions on a distant boundary. The implications are far-reaching and deeply profound, opening up new avenues of research and potentially revolutionizing our understanding of the cosmos. It's a journey that will take us to the very edges of science, where the boundaries between the known and the unknown blur into a tantalizing mystery. So prepare yourself as we dive into the top 10 theories about the holographic universe. From the paradoxes of black holes to the mysteries of quantum gravity, we're about to embark on a journey that will challenge your perception of reality and redefine your understanding of the universe. We start our countdown with number 10, the black hole paradox. This puzzling conundrum arises when we ponder the fate of information that tumbles into a black hole. Picture this. You're holding a book, a collection of information. If that book falls into a black hole, what happens to its information? According to classical physics, it's lost forever. But quantum mechanics disagrees, stating information can never be destroyed. A paradox. Now enter the holographic principle. It proposes that all the information in our 3-dimensional universe can be encoded on a 2-dimensional surface, like a hologram. So, when our book falls into a black hole, its information is not lost but rather encoded on the black hole's event horizon, the boundary beyond which light can't escape. This theory redefines our understanding of black holes and sets the stage for more complex theories. At number 9, we have quantum gravity. Quantum mechanics and general relativity are 2 pillars of modern physics, yet they are fundamentally incompatible. The former deals with the tiniest particles in the universe, while the latter explores the vast cosmos. But what if we could reconcile these two? Enter the holographic principle, which suggests that all the information in our 3-dimensional universe could be encoded on a 2-dimensional surface, much like a hologram. This radical idea could help unify quantum mechanics and general relativity, giving birth to a new theory of quantum gravity. Just think about it. The entire universe, with its galaxies, stars, and black holes, could be a holographic projection from a flat, 2-dimensional plane. It's a mind-bending concept that challenges our perception of reality. This theory could be the bridge that connects 2 fundamental yet contrasting theories in physics. Coming in at number 8, the universe as a hologram. Imagine, for a moment, a hologram. It's a 2-dimensional surface that, when light is shown upon it, projects a 3-dimensional image. Now, take that concept and magnify it to an astronomical scale. That's the idea behind the theory we're discussing now. This theory suggests that the entire universe we inhabit, with all its vast expanse and infinite details, might just be a giant hologram. It proposes that all the information of our 3-dimensional reality is encoded on a 2-dimensional surface, much like a hologram. When light or energy interacts with this surface, it projects the three-dimensional universe we perceive. This isn't just a fanciful idea, it's a concept that has been explored and studied by some of the world's leading physicists. It's a theory that fundamentally challenges our perception of reality, prompting us to question the very nature of our universe. This theory fundamentally challenges our perception of reality. At number 7, we delve into string theory and holography. This is where the holographic principle dances with string theory, a theoretical framework where the point-like particles of particle physics are replaced by one-dimensional objects called strings. String theory is a bold endeavor, attempting to describe all particles and fundamental forces of the universe, from the tiniest quarks to the grandest galaxies. The holographic principle shines here, as it's a key component, suggesting that all the information in our three-dimensional reality might just be encoded on a two-dimensional surface. Imagine this. The universe as we know it is essentially a 3D projection of this information stored on a distant 2D surface. String theory and the holographic principle together create a fascinating symphony of physics, offering a new lens through which we can view and understand the cosmos. It's like a cosmic detective story, with scientists piecing together clues about the fundamental nature of reality. This theory could revolutionize our understanding of the very fabric of the universe. Number 6 brings us to the information paradox, a brain-bender that has puzzled physicists for decades. You see, in our known universe, the law of conservation states that information can neither be created nor destroyed. But what happens when something like a black hole, a cosmic vacuum cleaner with a no-return policy, enters the equation? This is where the paradox arises. If a black hole swallows up everything, including information, and then evaporates over time, as suggested by Stephen Hawking, where does that information go? Is it lost forever, violating our conservation law, or does it reappear somewhere else in the universe? Enter the holographic principle, our theoretical knight in shining armor. It suggests that all the information sucked in by a black hole is actually stored on its event horizon, the boundary around a black hole from which nothing can escape. So the information isn't lost, it's just moved. This theory could redefine information and its role in the cosmos. At the halfway mark, we explore holography and thermodynamics. The holographic principle suggests a fascinating twist on thermodynamics, the branch of physics that describes heat, energy, and work. In the realm of the cosmos, black holes play a pivotal role. When a black hole forms, it eats matter, effectively erasing all the information about what fell in, creating what's known as the black hole information paradox. But here's the catch. The holographic principle proposes that all the information sucked up by a black hole is actually stored at its event horizon, the point of no return for anything falling into it. This has profound implications for thermodynamics. It implies that the second law, which states that the total entropy or disorder of an isolated system can only increase over time, applies to the whole universe. This theory takes a fundamental law of physics and gives it a cosmic twist. Coming in at number 4, the CFT Correspondence. This mind-bending conjecture in theoretical physics is all about making connections. Think of it as a cosmic translator, bridging the gap between gravity in one universe and quantum field theory in another. And it does this through the lens of the holographic principle. In simpler terms, imagine a universe where gravity rules, like ours. Then picture another universe without gravity but teeming with quantum fields. The CFT Correspondence suggests these two universes can be described by the same mathematical language, just as a hologram can encode a three-dimensional image on a two-dimensional surface. Does this sound like science fiction? Well, it's not. This theory is actively researched in the world of physics. It's a potential game changer, a major breakthrough that could revolutionize our understanding of the cosmos. This theory could be a major breakthrough in our quest to understand the universe. At number 3, we have the holographic brain. This theory embarks on a fascinating exploration into the complex labyrinth of our brain. It postulates that our brain may function based on the principles of holography, instead of storing information in a three-dimensional format. The brain could potentially store it in a two-dimensional format that can subsequently be represented in 3 dimensions. Imagine this: a flat, two-dimensional image containing all the necessary information, morphing into a detailed 3-dimensional representation. This could be how our brain processes and stores the vast amount of information it encounters daily. Through this theory, we might be able to unlock a deeper understanding of not just the universe, but also of our own cognitive functions. The holographic brain concept pushes the boundaries of conventional neurological theories, proposing a bold and intriguing approach to deciphering the enigma of our brain's functionality. This theory is a testament to the potential extent of the holographic principle, just missing the top spot at number 2, the multiverse hologram. Now, we're diving into an even more mind-boggling theory. What if every universe in the multiverse is a hologram in itself? Imagine each universe as a unique painting, with every detail, every stroke, every color, encoded on a two-dimensional canvas. This concept suggests that each universe within the multiverse has its own two-dimensional surface that encodes all its information. It's as if the universe we live in, and potentially countless others, are intricate holograms projected from these surfaces. And if that's not enough, consider this: these holographic universes might be interacting with each other. That's right, the laws of physics and the course of events in one universe could be influenced by the holographic projections of others. It's a theory that pushes the boundaries of our understanding, turning the vast complexity of the multiverse into a network of interacting holograms. This theory takes the holographic principle to an even grander scale. And finally, at number 1, the holographic principle as the theory of everything. Picture this: a theory that could unify all of physics, linking the vast cosmos to the tiniest particles. This is the tantalizing promise of the holographic principle. But what does it really mean? Well, in essence, it suggests that all the information in our 3-dimensional universe may be encoded on a 2-dimensional surface, much like a hologram. This is a radical departure from our usual understanding of the universe, and it's not without its challenges. Firstly, it's worth noting that the holographic principle is still a conjecture. It's not yet a fully fleshed-out theory. It's a concept that has emerged from string theory and the study of black holes, but it's yet to be proven. It's a tantalizing possibility, but it's also a mind-bending one that challenges our understanding of reality. One of the biggest challenges facing the holographic principle is how to test it. How do you prove that our 3-dimensional universe is actually a hologram? It's a question that has puzzled scientists for years, but despite the challenges, the potential implications of the holographic principle are truly groundbreaking. If the holographic principle is correct, it could revolutionize our understanding of gravity and quantum mechanics. It could provide a unified theory of everything, linking the large-scale structure of the cosmos to the tiny quantum world. This would be a monumental breakthrough in physics, comparable to Einstein's theory of relativity or the discovery of quantum mechanics. The holographic principle also has profound implications for our understanding of black holes. It could solve the infamous black hole information paradox, suggesting that all the information that falls into a black hole is actually encoded on its event horizon. And so we come to the end of our journey through the top 10 theories about the holographic universe. Each one is fascinating in its own right, but none more so than the holographic principle. This theory, if proven, could change our understanding of the universe forever, making it the most fascinating of our top 10 theories about the holographic universe. As we reach the end of our journey through the holographic universe, it's clear that these theories offer a new perspective on the cosmos. We've traversed the fascinating landscapes of quantum gravity, ventured into the paradoxes of black holes, and even dared to view our universe as a hologram. Along the way, we've uncovered the intricate ties between string theory and holography, grappled with the enigmatic information paradox, and explored the intriguing relationship between holography and thermodynamics. We've delved into the CFT Correspondence, pondered the concept of a holographic brain, and even expanded our horizons to the idea of a multiverse hologram. Each of these theories, as audacious as they may seem, could potentially reshape our understanding of the universe and its workings. While these theories might seem out of this world, they could very well hold the key to understanding our universe. Until next time, keep exploring the mysteries of the cosmos. As we conclude our voyage into the enigmatic holographic universe, it's evident that the quest of science is ceaseless, perpetually querying and unearthing. Each theory we've pondered today, no matter how bold and alien it may appear, carries with it the prospect to revolutionize our apprehension of the cosmos. The true splendor, however, lies in disseminating these revelations, these insights, these bewildering concepts. Our expedition doesn't cease here, it's merely the onset. So, what's your take? Which theory captured your imagination? Was it the paradoxical black holes, the multiverse hologram, or the idea of a holographic brain? If you've gained some fresh knowledge from this video, please do hit the like button and share your opinions in the comments below. Don't forget to subscribe and tap the bell icon for more such enlightening content. Also, don't hesitate to share this video with your friends and family. Let's sustain this journey of learning, questioning, and most importantly, sharing. Until we cross again, continue your exploration of the cosmos's mysteries.